Hi, it's me, Mr. B. In this video, we're going to talk about normal distribution. Normal distributions are symmetrical with a single peak at the mean, average of the data. The shape of the curve is described as bell-shaped, with a graph falling evenly on either side of the mean. 50% of the distribution lies to the left, and 50% lies to the right of the mean. All right, so what that means is, normally you're going to hear this talked about as a bell curve or the curve, and it looks like that, where most things are, and I didn't draw that right there in the middle, so right about there. So that's the mean. Most things are going to be right in here, right around the mean. There's going to be fewer and fewer things farther and farther away from the mean. That's what the layman's terms of a normal distribution are. We'll talk about several examples, but here are some here. Heights of people. Most people are right around the average height. And as you get farther and farther away from that, there are less and less people there. So there's very few people that are really, really tall. There's very few people that are really, really short. Most people are right around the average. Size of things produced by machines. Machines will always produce, things that are really close to what they should be, but, just depending on how the machine is set up or the humidity in the day or the material that is being used, there are lots of factors that go into it, but, sometimes it's going to make things that aren't quite right, but most of the time it will. Blood pressure and IQ tests. We'll talk about IQ tests here in a second. All right, so here's a picture, and you're going to see these, once I show you this, you're going to see these all over the place when you go out. This is a door, and you can see right here, as I draw on the door, right there, that's a normal curve right there. So the average is right there. So that's where most people hold the door. So you can see as the paint has worn off over the years, as people touch this door, most of the people touch it right in this location right here. Very few people touch it up here, and very few people touch it down there. Most people are right around the average or the middle, the mean. And this happens all over the place. It happens with tread wear. When people walk in a certain spot, you'll see that place wear more. But you can really see it here as over the years as people touch this door, and there's examples all over the place. As you go out, you'll see these kind of things happen. All right, so here's a bell curve, and this is what you have in your notes. And so we're going to go ahead and draw on this, and right here is the mean. Let me go ahead and shrink my pen size. So that's the mean. And now I'm going to go one standard deviation above the mean. That's that line right there. This is 2 standard deviations above the mean. This is 3 standard deviations above the mean. And then you have another little tick mark out there. That's 4 standard deviations above the mean, but we're not going to mess with that right now because once you get out past really 3 standard deviations, it's a very rare occurrence that something is out there. All right, let's go below the mean. So if I subtract a standard deviation, I'm right there. If I subtract 2 standard deviations, I'll be at that second mark. And if I subtract 3 standard deviations, I'll be at that third little tick mark there. All right, so we have this thing called the 68, 95, 99.7 rule. And it says this. If I go out 1 standard deviation from the mean on both sides, approximately 68% of all the data lies within 1 standard deviation of the mean above or below. So like for heights of people, 68% of people are within 1 standard deviation of the average. Now, if I go to 2 standard deviations above or below, I should be able to catch more examples in a data set. So 2 standard deviations above the mean, approximately 95% of the data lies within 2 standard deviations above or below the mean. So using heights, 95% of people are within 2 standard deviations of the average height. And then you go out 1 more standard deviation on both sides, and if I draw that turns out to be 99.7% of all data is within 3 standard deviations of the mean above and below. So for heights, of 1,000 people, 997 of them would be within 3 standard deviations of the mean. That means 3 people would be taller than 3 standard deviations above the mean or smaller than 3 standard deviations below the mean, which is extremely rare. Now the 68, 95, 99.7 rule actually has a real name. It's called the empirical rule, but the name of it doesn't matter. It's the numbers that matter. So you can go ahead and draw that in your notes. So in your notes, you have approximately 68% of the data is within 1 standard deviation of the mean. 95% of the data lies within 2 standard deviations of the mean, and 99.7% of the data lies within 3 standard deviations of the mean. All right, so here's the normal distribution for IQ tests. The average IQ is 100. It's scaled that way. So if you were exactly the average intelligence, then your IQ would be 100. The standard deviation is made to be 15. So if I add a standard deviation, add another standard deviation, and add another, and then you can go on the low end as well. So if you subtract 1 standard deviation, so 15 from 100, you get 85, and so on. So as you can see here that 68% of the data, 68% of people have IQs between 85 and 115. Now if I go to 95%, which is 2 standard deviations above and below the mean, that means 95% of people have an IQ between 70 and 130. Now 99.7 is not shown here, but 99.7% of people, so almost 100%, not quite, but almost, have an IQ between 55 and 145. So there are people that are geniuses that have IQs above 145, and then there are people that have IQs that are below 55. All right, so here's an example. So I want to draw my normal distribution here. So recent studies suggest that the mean body temperature, the average body temperature, is 98.2, not 98.6, with a standard deviation of 0.7 degrees Fahrenheit. Draw and label the normal model. All right, so the mean goes in the middle. So that's 98.2. Now I'm going to add and subtract standard deviations. So I'm going to go 1 standard deviation above. So 98.2 plus 0.7 is 98.9. If I add another standard deviation, so 98.9 plus 0.7, that's 99.6. And then if I add another standard deviation, that would be 99.6 plus 0.7, which would be 100.3. Now if I go below the mean, 98.2 minus 0.7, that would be 97.5 degrees. 97.5 minus 0.7, that would be 96.8 degrees. And then 96.8 degrees minus 0.7 degrees would be 96.1 degrees. All right, so now I can go ahead and label this. So that's 68% of all people have a temperature, a normal average temperature between 97.5 and 98.9. Now if I go to 95% of the data, 95% of people have an average body temperature between 96.8 and 99.6. And then finally, if I go 3 standard deviations away from the mean, which encompasses 99.7% of people, they have average body temperatures from 96.1 to 100.3 degrees. So there are some people that have average temperatures around 96 or around 100, but most people are right around the average, around 98.2.